Hi there. So today we start somewhere different. Welcome in my small forest where I do some wood chopping, or better, chainsaw cutting. Um, you might wonder why I start here today, but it's a good place to show what is possible if you have your data in your pocket. Because I want to talk about the Seamless Auxiliary Data Archive, and I want to show you what is possible if you have everything in a mobile phone. So it doesn't matter if you're in the forest or if you're at the observatory, you have all of your data inside your mobile phone, and you have direct access as long as you have access to the base station for your mobile phone or to a wireless LAN. So let's start, and I'll show you what is Seamless Auxiliary Data Archive. So, welcome. I changed back to my office, or better to my home office, to show you what I mean if you have your data in your pocket. You see all of the status information from the Wetzel observatory, from the radio telescopes, and today in my presentation for the technical operator workshop organized by the Haystack group, or by the Haystack guys, I will present what I do for the IVS Seamless Auxiliary Data Archive. And I focus onto the specific things for operators at the radio telescopes. So therefore, let's have a look into the different aspects and where you have some benefits as an operator using the data archive and maybe participating to the data archive. I want to show you a few different aspects of the data archive. So first of all, let's talk about what is the IVS Seamless Auxiliary Data Archive. What is it used for, and why did we create it, and why is it at Wetzel? And then I want to talk about where are the benefits. So why should you use it as an operator, and where can you improve your work with this data from the data archive? The third part is, how can I participate to this data archive? Because the archive just lives if you all send in data and if you use the data. The archive will be used by the analysts and also maybe by the correlator guys. And if you also have some benefits, then it's a win-win situation. So therefore, you should improve your, let's say, data senders, your data acquisition systems, so that you feed in data to this data archive. And the fourth aspect is, I want to show you that this data archive is much more than what you use in the IVS Seamless Auxiliary Data Archive, because we in Wetzel, we use it also for the complete monitoring. So we do complete unattended observations with our radio telescopes, and everything is mainly based on this data archive. So all of the data from the racks, from the rack temperatures, from the status information of independent power supplies, from different temperature sensors, all of this data are sent into our local data archive, so that we have a complete overview about the operational conditions of our systems. So let's directly start with the first part, with the aspect, what is the IVS Seamless Auxiliary Data Archive? The IVS Seamless Auxiliary Data Archive is mainly based on ideas and implementations from the IVS Task Force for Seamless Auxiliary Data. It was founded in Shanghai 2014, and the main driver was that seamless data and auxiliary data are mainly available at the sites, at the observatories, For example, meteorological sensors, clock offsets, temperature sensors are locally in databases or files, but they are not available centrally. If they are available, they are in log files for the NASA field system so that analysts can access them. So they are not in equidistant sample rates, and they are only available for exactly this period of the session. And therefore the idea came up to bring these data continuously to a central archive with a simple technique, with a simple way, so that a lot of observatories can participate. And with a changing aspect of remote control, which means that mainly the focus should be put on monitoring, it means that the aspect of remote access and real control is completely reduced, and acquiring and centrally collecting of data is in the focus of this data archive. So what is the Seamless Auxiliary Data Archive? In principle, it's nothing more than a database. So what you do is you have a database. In our case, it's PostgreSQL, and you have a graphical user interface to simplify the access to the database. This simplification is done by a professional tool, which is open source. It's Zabbix. Others would be Nagios and other monitoring tools. And these monitoring tools offer a very sophisticated access method via HTTP, so via web pages. What you do is you log in with your account. There's one guest account for the IVS, which can be used by all of the observatories, all of the participants, from correlator guys, from analysts, from operators at the telescopes. And they are just guests, so they cannot change things there. They just can visit and view different data collections. So if you sign in, you get directly a world map with the current participants. There is one more. IVS will be included, and also AGO will be included here, so that it's a work in progress. And at the moment, we have a change to a new official key file or certificate, and therefore it might be necessary that you accept the risk of a not certified key with your browser. What you can do then in the background, as I said, is the PostgreSQL database. And what you then can do is you can access this data directly from the world map, and you directly click on data, and you see then the graphs. In our case, for example, the clock offsets, the temperature, the pressure, the humidity, and the wind speed and wind direction. If you don't have all of this data, it's not a problem, because you can send in just parts of this data, and this is also the, let's say, starting data set which you should support. You have much more, I will show later. What you then can do is you can select different time periods, for example, and you directly see the advantages. For example, you see times when there are outtakes or when there are blackouts of your data, like here where we had a network change. And you also see the trends and also small ripples and small different periods of your data, so you have direct access. And then you can directly use this to zoom in, and you directly see the time when the error or the critical situation happened, and then you can react on this situation. You have different possibilities in this case. You can directly acquire all of this data, for example, of the different participants. This means that you will see all of the data from the different telescopes, and you directly see, for example, trigger levels, which are error states or warning states, for example, that some data do not arrive within a special time period. This is the main and basic part which our IVS Seamless Auxiliary Data Archive offers. There is another more sophisticated part where we can request more data from the field system, so that you can use this more or less extended version. So if we change to our field system screen, you directly see, for example, the set of frequencies for different sessions. You directly see the system temperatures and changes in the system temperature. And you see all of the other parameters, also, for example, azimuth and elevation positions, or the status of your Mark 5 or Mark 6 systems. In general, you have the possibility to use a lot of data. In our case, there are 234 items. You have only half of these items as real data. The rest is a mechanism to fetch data automatically. So you have two possibilities. You can send data, or you can let the system fetch data. And to apply these to the system, it's possible to directly start a mechanism here to fetch the different data. So therefore, in principle, you have about 120, 115 different data sets, and the same number of fetching mechanisms where you get a value if the fetch worked or not. So you have all of these different data like ACU errors, or in this case azimuth, cable, catalog year, checks, all of the things which you know from the NASA field system. So you can send in all of this data, like source names and system temperatures in the legacy system. You can send in this data, and then you directly have this possibility of plots. These plots are automatically generated, so if you send in data, then you can directly access the data as plots. For example, you can directly see the DUR status or the DUR temperatures, and you can also see the different error outputs in your field system in a history. So if you go into this, you can select, for example, the different time periods, and you see all of the error and warning situations in your field system logs, which are automatically recorded. So this is quite helpful, and this is quite nice. So what you have is, you have a very simple access to this database. This means that you don't have to know a lot about the principles of databases. You don't have to know a lot about, let's say, SQL requests, things like that. You have a very simple application interface, which means you can send in data and you can request data. The requesting and sending can be done via an HTTP interface, and we also offer different mechanisms like scripts to do this. You have a nice access to your field system data, and you can decide what you send in and what you really want to share with the community. It also offers much more. So we use this for the monitoring of the whole systems in Wetzel. This means we run all of our sessions meanwhile unattended. There's only one central control operator who also controls laser ranging systems, and he has a screen available in the background which triggers some activities or some sound effects. So if there are errors, you will hear a sound, and then you know that you have to do something. So I can show you this, what the operator usually sees. It's a map of the Wetzel observatory, and if there is an error, you will see highlighting with a different color around the different telescope or operation part, and then you can react on this. So you directly see also what happens, and you have a history of events here, so that you directly have access to your system. And if there is an error, you will hear different sounds, so that you will directly see that you have to interact with your system. And with this, you can directly have access to the different possibilities of our remote access system as well. So it's much more than what the IVS Seamless Auxiliary Data Archive allows to do. For example, we can also directly request the monitor of the field system as an HTML output. So if I go to the Wetzel telescope, I directly see the current status of the Wetzel telescope, and it automatically adapts to the speed of the internet connection. And what you can also do is you have access to different other outputs. For example, I can have a look into our operation building racks. So this is the monitoring of the operation building racks, and if I go to the corresponding screen, then I can show you if the cooling and the mechanism works there to keep the system in a stable state. Okay, so here you see the cooling cycles and things like that. And what you also have in this extended version is, for example, a Mark 6 output. So if you want to have a look into your Mark 6, you directly see the different hard drives. We have extension chassis, so therefore we have 4 8 packs, and you directly see the filling state of the different hard drives there. You see that, for example, some cases we use some hard drives for the gathering and things like that. And you see if the data streams appear, so if they arrive at the system and if everything works correctly, also on the CPU, so that you have a complete overview of your system. But this is the extended version, so let's jump back to the basic thing what we have available here. This is the IVS Seamless Auxiliary Data Archive, the main part where we currently want to collect a few things: the clock corrections, DOTMON, GPS minus FM out, the temperature, humidity, and pressure, so meteorological sensors, wind data, things like that, which is a elementary main part for the analysis, and we want to have them continuously. So this is the IVS Seamless Auxiliary Data Archive. As you now know what the data archive is, we want to talk now about the benefits for you as an operator. So if we jump back to the data archive, then One benefit is that the data archive is centrally at the Wetzel Observatory. It was funded, for example, partly, or some interactions and implementations were funded by some projects. One was the Jumping Chive project funded by the European Union, so that we got money for this implementation, or for parts of this implementation. And the server is also located at Wetzel, so this means you don't have to spend money and you don't have to spend a lot of work for this. You have to spend a little bit of work to send data, to adapt, to implement your programs, where you can get support by the technical part of the IVS, for example, Stuart Weston. But the rest is completely in Wetzel. And the nice thing is that we have everything in templates. So here we have the templates for the NASA field system with all of these items. So all of these items which are defined here can be used by you, and you can send in this data. And I already explained that we have a lot of items which you can already use. So this central aspect is quite helpful for you, because you don't have to have it locally. You just send in the data via the internet, and then you directly have access with your, let's say, private account or with a guest account, so that you can directly check your data. A very important aspect is that you directly see error situations. So if you have the monitoring here, this world map on one of your screens, then you directly see error situations. For example, here what I showed in the video before, if there is a blackout, so if you have a data loss, you directly see it here, and you will get an error information, so that there is a data loss. You also see trends, so you can have a look into your data of the last days, of the last month, things like that, and you have them continuously. So you can directly see if there is a critical situation in the trend, or if you have some problems in your data. It just lives from the data, so you have to send in the data. And with this, let's say, main basic set here, the benefits are reduced to this, but it's up to you what you want to use and what you want to see in your data. And as I said, you can use all of this data. And we have already defined a lot of triggers, so it triggers on all of the log file errors. So if you use the log file information and you send in the log file information, or just the errors, you have a central repository where all of the errors appear, and where you will get triggers on these errors. So in a first setup, all of these, let's say, triggers, these alarm levels are reduced to the minimum, so they are disabled. But you can enable this in your account, and then you have directly the possibility to get an information and an alarm level if something happens during your session. And another nice thing is that you directly have the graphs available. So as I showed you, even if you don't have the central overview, you can directly go into your system, and you can get a graph for all of your levels. So for azimuth positions, for example, and you can get the data of all azimuth positions for the last, let's say, 3 months, for example. And if you combine this then, for example, to count levels in your DBBC, in the different bands. You might use it also for the RFI monitoring or things like that into special directions. And the graphs are automatically available, so you don't have to do some programmings and things like that. You just use the data, you just use the overview here in this latest data set, and you can directly jump into the different sets, for example, into the system temperatures. This is quite helpful and is quite nice if you just have everything with one click available, and you have it also available in your mobile phone, in your mobile device, on your desktop PC, at home, and as I showed you, also in the forest if you need it there. So the next step is that I want to show you how you can activate your participation to the system. So let's jump to the next part in my presentation. How can I participate to this repository? The participation is quite simple. In principle, you just have to send in data. So how can you do this? This is quite simple because SAPEX and our scripts around offer all of the possibilities. So for example, you use a program which is called SAPEX Sender, and then you define the IP, the port, and the host. The host is your antenna name. Then the key, this is the item or the value which you want, or the name of the value which you want to send in, and then the value itself. So if we, for example, send in a temperature in our test host, then you directly see that it works, you get feedback, and if you watch it, you directly see the output in the graphs. So if I do this again, and if I change the value, for example, to 30 degrees Celsius, and if I update this, then you see directly the output. So this is quite a simple mechanism which you can use to send in data. The program is installed locally on our server, so you don't have to install a program on your side. The question now is, how can you get access to this server here? So how can you get access to this program? And therefore you have to request an account. So send an email to me and I will give you an account, a special name and password, and also what is quite important, a key file. So you can send me a key file, or I will produce a key file for you which is installed especially in your account. The account is based on the antenna name, so you will get one account for your antenna, and then you can access to a local user. All ports, so everything what you see here, so all what I use here is blocked by our firewall, so you have to be on the machine, so therefore you have to use SSH, so a secure shell connection, to access the machine, and you need the key file. If you do this, you will appear in a reduced remote bash. It's a special script, it's a special shell which I wrote so that you cannot destroy anything, or that you're locally kept in your directory. So it's very protective against attackers, and you just have a few commands which you can use in this shell. So you can echo things, you can call the SAPEX sender, so you can send in data, and you will have the possibility to request the local date, so that you can use this date for your mechanism to send in data. In this case, what I showed here, the date will be from the central observatory or from the central repository. If you want to use it from the observatory, so at your location, and if you want to avoid influence from the transfer times, then you can also use your local time and you can send in the data with your local time. What is now necessary? You use an SSH call. Here is a sample SSH call, and this SSH call just uses some flags to avoid the known host mechanism. Then you use the user. I use here the standard user from the field system, but you will have your own local user like with cell for with cell antenna, for example. Then you will get this key file. So you will use this key file here to get access to your remote bash, to your shell, and you use the alias or the IP address of our central repository. So the IP address is or the alias is vilby.susmon.evilbi.wetzel.de. And then you start a remote command. This remote command is in principle an echo command where you prepare a table or one line of a table or a few lines of a table so that you can also send in multiple data to this. And I will move it up here. So each table line looks like this. You have the name of the host. You have the name of the item or the key of the item, which is the value name. Then you have the timestamp. The timestamp currently is in seconds, in Unix time or Unix epoch. You use these timestamps, so therefore you can send in data in an interval or in a sampling rate of 1 second. At the moment we use sampling rates of 1 minute or 5 minutes, so it should be often enough. So each minute you send in one sample of your data, and then the fourth table part here, or the fourth part of this line, is the value itself. The value itself should be tagged by a quote, so that you can also use blanks in text values and things like that. For numbers you don't have to use these quotes, but if you automatically use it, it's simple. So you use the host name, which is your antenna name. It's always combined with this 000 NASA field system, because if you have other screens, then this number will change. So for example, for Wetzel 000 NASA field system, then you have all of the possibilities from this template which I showed before, and then you have this key, the time in Unix epoch, and the value, and then you pipe this into the SAPIC sender, and you call the SAPIC sender with this call. You replace this port with a port which you get by me, and then you can send in the data, and then you directly have access also to this IVS guest. So this means you can directly go to this IVS guest. You go onto your location. Your location will appear then on this map, and then you go to this location. You select the IVS seamless auxiliary data part here, and then you will directly see the data from your antenna. And from this point on, you have directly all of the possibilities. If you now want to make it a little bit more automated so that you don't have to send in the data manually, then you have to update your programs. And this is also quite simple. For example, here I wrote a small C script. You can do this with Python, with a normal shell script, all of the possibilities. It doesn't matter, because the only thing what you have to do is you add, in addition to your already existing program. For example, here I request my .mon value from the counter. You add this part here. So for example, I do a conversion to the Unix time epoch, and then I create a string, which is my command. In principle, it's nothing more than this command which I produce here, and then I do a simple system call. So I produce this command and I send in then this command to the system. And in this command, I update the values automatically. So each time if I call this command, the new value will be sent. And then this is called each time I want to send the value, or it is in a while loop, so that I have a short wait state here. And the wait state will do the sampling and will send in the data in the correct way. So you see, it's quite simple to send in data. It's quite simple to request data. You don't have to have a lot of knowledge about how the data are stored and what is the background of this database. You don't have to have knowledge about the database itself. You just use this and you send in the data. The next question is, how can you use the data? So you can use the data in this style. So you can request the data using the web page. Then you have a graphical output. But if you want to use the data also for your programs later on, or if you want to use own plots and things like that, or if you want to use it for the processing in some analysis, then you need a possibility to request data again. And the requesting of the data is also quite simple, because you get a script, a Python script, which students and I wrote. So you see everything what you need. The complex things are already solved on our side, and you just use this. The program which you use is a Python script called Zapix API. It uses the standard API from the Zapix, and you call it, and if you call it without any parameter, you will get a README file with all of the possibilities. So let's scroll up. If you watch this, you can request which hosts are available. What you need is a key file, or what you need is an account file config with a password and things like that. You will get this Zapix API Python script and the config file if you request your account data, and then you can use it. So you call it, and then you can use this config file to request data. So you can request which hosts are available, which items are available per host, and you can select data. You can select single items. You can select also parts or intervals of the data, so that you can produce, for example, daily files, or that you can produce files for 1 hour with equidistant items. This equidistant is, of course, dependent on how often you send in the data. And if you use your local time, as shown in the program, in the C program, so if you produce the epoch with your local UTC, then it's automatically arranged to the timestamp which you produce, and you avoid some delays during the transfer. I want to show you a few features of this program here. So if you call it, for example, with the -L option, then it requests all of the possible hosts. At the moment, the possible hosts are the existing antennas. If you want to see which items or which values are available per host, and these items are of course the items of the template, then you can either use the host ID or the host name. So if we go to Wetzel, for example, the Wetzel NASA fill system, then we have this 10.133, and then you will see all of the items which are available. So for example, if we go to Wetzel.mon, or if we go to ERC, so then you see the differences. What I did not tell you until now is that you can of course extend these items. So you can get also something like an administrator account for your local items, and then you can extend your template set with individual items. For example, you set then these items with this antenna name and then dot and the value name, and you can extend the predefined items. There is a naming convention. ERC is the official, let's say, items which I offer to you, and then the other items must have these tags of your antenna name and the item name. So if I want to use the official item ERC humidity, for example, I can use this item name here. So ERC humidity, so I can use this key, or I can use the number here again. So I will use the key here, so ERC humidity. So I call it again with this host name and with the key ERC.humidity, and then I will get the last values, or the last available values of the humidity values at Wetzel. If you want to request the data for a special time period, then you can have the look into the README again, and you will see that if you call it with this time start and with this time end value, that you can select individual time intervals, so that you get a list of values for this time period. And then you can also use it to store it into a file. You can limit it to a number of values with this lim argument. You can do a different order. You can order it ascending or descending, and you can use this file storage mechanism here. For example, if you use -f, then all of the values which you request are stored as a table in a text file. At the moment, there is also the plan to produce VSDB outputs. It's not finished at the moment, but text files are available, and you can use these text files. So what you see is that with this SSH call and the SAPIX sender, or the sender mechanism, you don't have to install any program at the location of your site. So it's nothing what you have to install. Then you send in data with the account data, or with the account information, with a key file. You send in data to the repository. You have direct access via the web page, and then you can also request the data, and the requesting is also quite simple, because you will get this Python script and use this Python script to request data if you need it again for local processing. I hope that your appetite is now a little bit created to use this, and therefore I hope that you will join the data archive and that you will use it, because as I said, you don't have to have knowledge about SQL, you don't have to have knowledge about a lot of programming abilities, because you can use your local programming technique. So if you use C or C++, or if you use Python, or if you use scripts, or if you use Fortran, You just have to use a system call, and then you can directly use everything what the data archive offers. With this, I finished the how can I participate section, and then I want to show you a little bit what is also possible, what can also be done with this. And here is also the part where Jumping Jive project is located, or mainly located, and it goes much over this because we use it for a complete control monitoring at Wetzel. So also the laser ranging system, all of the other parts are controlled locally and monitored with these techniques, and therefore there are a lot of more possibilities which can be used here. First of all, I want to show you a little bit about the different, let's say, mechanisms which are possible. What I explained until now is the basis or basic possibility, and there are different more. Due to the different application cases and the different projects, the Seamless Auxiliary Data Archive is just one part of the complete set of mechanisms which are installed on our central repository. We have different possibilities for participation. So, for example, what I already discussed is the basic user. The basic site does not have to install anything at the location of the site. So you just use programs which you already have, and you extend it with this remote access on our repository, so that you make an SSH connection and you will get all of the possibilities, and you have to program the sending of the data. You decide how often you send data, you decide which data you send, and you don't have to install anything, and you have all of the possibilities from the repository for this specific data. This is the IVS Seamless Auxiliary Data Archive part. Then we come to a more sophisticated part. This is the standard side. The standard side is a side for which we produce the Jumping Jive developments. It is based on techniques where more or less things work autonomously or automatically to get the data. So you have to install a little bit of software, and then this fetching and this data acquisition is done autonomously by the server, by the central repository. And what is also very important is that you have all of the possibilities automatically what is offered by the field system, as long as the field system is active. Nevertheless, you can decide which data you really want to send. It depends on the web pages which are produced. I will explain later. And then you have this premium side. Premium side is currently just for the BKG or TUM sites. So it means for antennas which are operated by the staff at Wetzel, because here you have a complete overview. You also use techniques from the monitoring system, which means you directly take data also from servers. So you monitor servers, you monitor PCs, you monitor equipment like rack temperatures, things like that. So what you have is, you have these simple possibilities here, this basic side. You have a little bit more extended possibilities here based on these simple techniques with a little bit more automation. And here you have real complete control, or you can extend it to complete control. So I want to explain all of these things in a very fast walkthrough, and then we can have a look into these different possibilities. Before I show you these things in detail, again, a short overview about these three different participation possibilities. So the first one is the elementary value set. We use just a reduced number of values or items like .1, .2 for VGOS, temperature, pressure, humidity, wind, and maybe cable. You have a basic monitoring screen. You saw this screen already in the web page demonstration, and you have this simple data injection mechanism with this SSH commands, which you include into your local programs. The standard side uses, do you remember, the eRemote control software? The eRemote control software was developed to really control remote side. Here it is now extended with a special web server, so that it offers 112, 120, depends on what you activate, values which come from the field system or extended systems like the antenna control or the antenna unit. And this remote control software can be reduced to just produce these web pages, so that it is more or less a simplified web server. And then you have this basic monitoring plus the field system screen, which means you have all of these possibilities with all of the values. And the data injection is done automatically. You have to implement, or you have to allow to get a complete connection or a fixed connection, which is an SSH tunnel between the server and your field system PC. So it's a little bit more administrative necessity. The premium side is then the complete control side. As I said, it's just developed for WetCell, for the WetCell needs. And it can also use individual monitoring things. For the standard side, you can also extend your parts, so you can also extend the items if you want an administrative account for your special site, but you have to do these programming things for yourself. In the premium side, there are special templates which are already prepared, and they are used for the WetCell antennas, and you can have independent power supply monitoring, sensors, racks, and all of these things. So it's a very individual monitoring, and it uses the data injection plus the specific SAPIX API methods to request and to send and to get data. So it's more or less the premium side is more or less the WetCell side and cooperation partners. So there are these three different possibilities, and I want to show you especially the standard side and what you have to do. Again, the basic side is for the IVS archive, the standard side is more or less developed for the jumping jive part, and the premium side is developed for control centers focused on WetCell. So let's first of all focus on standard sites. Standard sites work with this eRemote control software. So therefore, you have to install this eRemote control software, which means that you use this already known stack, where you don't use this remote part of the eRemote control software. You just use the data access, which is the FS monitor, which accesses or acquires data from the field system and other parts, for example, from Linux or other equipments. So, and this part is now extended with a web server, with a very, very simple web server, just allowing to send out specific, very specific web pages. There is no possibility to go through directories. It's just all web pages must be stored in one special directory, and the data there are just available if you set it in special configuration files. So therefore, you have to configure this remote control web server, and you do it with a configuration file, and then you have web pages. There are standard web pages which you can use. In principle, they are HTML files. These HTML files are in the moment under a rework, so that they are not so power or let's say network consuming, and you can use them. So you install the complete package here. So this one. You install the complete package here, and then you define the web pages and the content of the web pages, which are then distributed by this simple web server. The nice thing in these web pages is now that you will get a complete overview and a complete copy of your screen at the field system screen. So you have a complete copy in your browser. You see it here. It's a complete copy of the system status monitor, the Mark V remaining capacity, the system temperatures, though this is based on the legacy systems. There are also developments for the VGOS systems and things like that, but this is an ongoing process. You have the log files here, you have everything what you need here, and you can also define local specific station parts here. So if you watch this. And the trick now is that information which is shown here is tagged with special comment signs. So for example, if I go to this with cell tag, so if I go to the name of the antenna here, then you see on the side here that there is a special comment tag. There is a start tag and an end tag here. So ERC colon colon or ERC colon colon antenna is the tag for the name. Or if I go to the meteorological information temperature, you have ERC colon colon temperature. And then you have the information, and then you have an end tag, which is an empty comment. And this information is now used to extract data from this web page. So you avoid JSON or JSON RPC or whatever additional parts, because, for example, everything what is based on XML is also not really reduced in size. So you can directly transfer the web page, and then you have the possibility to view directly data in web browsers, and you can directly extract data for the processing. And this extraction is automatically done. Additionally, if you want to do this extraction automatically on our server, you need a connection to our server from your site, and therefore you need a possibility to establish a continuous tunnel between the server and your site. And for this, you can use the auto SSH script, which you can get from me if you request it. So what you use is auto SSH with a special key file, and then with some ports which you use as a reverse tunnel, and through this reverse tunnel the data will be fetched. It means the web pages will be fetched directly to our system. And then you have also these web pages available on our central repository so that you can access your local site, the things which you want to offer. You can access this data directly with on the alias VLBI Sussman, eVLBI Wetzel.de, so that from everywhere on the world you can request the data and the web pages. And the next thing is then that on our site, on our part of the service, there are special scripts which extract exactly this information. For example, .mon2 here, it extracts this data. The web pages will be fetched in special time intervals up to 1 second, and then it will extract the data from these web pages, and it will also use local timestamps, because the timestamp here is locally also created and will be used as a hidden tag in our extraction utility. And then it will be used to send in the data into the repository, and therefore you fill all of the data automatically. So what you have to do is, if you want to participate as a standard site, so not only for the IVS Auxiliary Data Archive, you have to install the remote control software. You have to reduce it to the web server situation, so you completely skip the remote control part of this software. You just use it as a web monitor web server, and then you establish a channel, a tunnel between the server on our side and your PC on your side. Therefore, you have to sign some administrative papers. So you have to make some cooperations. It's a little bit more work. So therefore, the simplest way is this basic site. So therefore, this is used for the IVS Seamless Auxiliary Data Archive, but you can do much more here. If you have this, then you can also use these additional screens. For example, for Wetzel, I can show you this additional screens. For example, for the Wetzel antenna, I already showed it to you. So these data, this additional screen is available if you use this automatic extraction mechanism. And then you have all of these possibilities also from the remote control software. Finally, I want to show you very quickly the additional possibilities for premium use. This premium use is what we use in Wetzel, and therefore I can show you some samples from Wetzel. So it uses especially things which are directly offered by SAPEX or by the monitoring system. For example, it shows, or it gives possibilities to automatically use templates for the monitoring of PCs, and therefore you can extend your monitoring with additional possibilities for PCs. So in this case, for example, you can check the processor load or the disk use and things like that. So for example, you directly get information about the available memory, and you have everything online. So it requests the data. There is a special agent installed on each of the PCs, on each of the servers which you want to monitor, and it automatically requests the data. It does also an exploration of the local system. So for example, if you change the hard drive or if you change the network, then you will get the new possibilities automatically. And then you will get this information directly from the system, and you have it available in your database, and you directly see it here in your web monitoring system. So it doesn't matter if I'm at home and if I get a phone call by a student or something like that, I can directly check what is the problem in our system. Another thing is, for example, what is very often used in our case, the SNMP requests. For example, here you can define SNMP requests like MIBs or traps, where you request specific data and the rest is automatically done by the monitoring system. So therefore you can request the battery status of independent power supplies, you can request rack temperatures, all devices which offer SNMP, some serial connections, some for example converters, everything what offers SNMP can directly be requested. An important thing is here is that you have to use some proxies if you have to go through firewalls, so therefore there are specific proxies installed locally behind the firewall, and there's a one-to-one connection directly to this proxy to get the data through the firewall, because the web server here is outside of our firewall, so that you can request it from anywhere on the world, and therefore you don't have to go all the time directly through the firewall. If you want to request data, the data are sent to this external device, and then you just request the data from this system monitoring server, so that you cannot influence your local system, or that you open door for attackers. You have everything just locally on your external system. So with this, you can then directly see the status of your independent power supply. So for example, of the input voltages, and if you have some battery errors, or if you run on battery, things like that. So this is possible, and with this you can also create individual trigger levels. For example, if the dewar increases, or the dewar temperature increases to a level which is critical, you can directly see this. So if you go, for example, to the dewar, to the dewar of the 13 meter dish, and if we watch the last 30 days, for example, then you see that there are some situations where it was critical, and you can zoom in and you see that something must be happening here, so that there must be some situation which caused this spike, and this 500 Kelvin is our default value, our value which shows that there is an error. And for example, at this time the network was switched off, or the dewar monitoring was switched off, and you directly see it here. So you can define a lot of different custom screens, and these custom screens also allow to create maps or special items on the maps which show trigger levels. And these trigger levels are organized hierarchically, so that, for example, a host is the first trigger level, then you can combine different hosts to one host group, and then you can define host groups to another host group, so that you get a hierarchical view. And for example, if all of or if one system in the antenna shows an error, then I will see it here, and I can then go through these different levels and can have a look into the system and also the parameters which cause this problem. And I have a history of the events, so that I directly see when this happened and what I have to do. And for example, we have it also for the guard, so that we have a translation into German, and then we can use the guard to call us. We have a 1 week all week a change of a call on service, so that we are on a call on service. So it changed completely from a operator on site on location to an unattended operation, and the guard or the system itself gives us a phone call and will tell us that there is a critical situation and that we have to have a check and have a look into the data. And if there is a critical error, for example, the guard will hear a sound like this here, or really critical like this, so that there will be a highlighting around the building where the error happened. For example, if the temperature increases or if we have a power outage, then it is directly visible where it is, and then we can directly force some activities and actions via phone or via some remote access. And this is why I also wanted to show you what is also possible. Modern companies, modern factories have this. For example, a heating plant has about 5,000 parameters which are monitored with such systems, and you have to define special critical situations. You have to define special administrative processes, and then you can run your antennas completely autonomously. This is not what I want to offer, of course, that we do all of these things here. It's just for the wet cell antennas, but I wanted to show you what is possible and that it is already used, because we at Wet Cell will run the antennas completely autonomously. So, and this is what I wanted to show you. So what is the Seamless Auxiliary Data Archive? What are the benefits for the operators? How can you participate to this data center with very simple techniques, where you don't have to install things on your side? And what is also possible, and what is a real benefit for the control center if you have to control more than one telescope from one local position from one control center. So this is what I wanted to tell you. Finally, if you have questions, feel free to contact me. You'll find all of the information here on our IVS Seamless Auxiliary Data Archive web server, and there will be also additional information. There is, by the way, a quick reference as PDF, which I can send out, or which will be on the download pages, and it will be also the complete reference with all of the information. Also, what are the scripts, how the remote shell, this special bash, is, and how it is created. So you find everything here in these documents, so that you can get access to this information and that you can participate in any way. So if you're a basic, standard or premium user. Of course, the premium user is just what we use. I don't want to offer this for the whole community, because it's a lot of work. This is what I wanted to tell you. Have a nice time. Stay safe and healthy. Take your vaccinations so that we can see each other again on the next workshops in real life, in real world. For example, at the next technical operation workshop at Haystack by the MIT group. And I say thank you for listening, and bye-bye. Stay safe and